name's Michael Williams from Raycastle, and I'm here today to discuss software-defined networking, or SDN. What is it? Well, it's software-defined networks. It's the third piece in the computing trilogy to be finally virtualized. It follows compute and store, which have been virtualized using virtual machines and storage area networks, or SANs. But back to SDN, what does this mean to me? Well, of course, it must mean a reduction in capex. That's true as far as equipment is concerned, but hang on, is that all that we're buying? According to Neil McRae, BT Chief Network Architect, there is going to be a substantial investment in software development. You will still need to spend as much capex buying good software. So perhaps it's more capex neutral than we first thought. From how we used to do networks to SDN, well, today's networks is based on 7 layers of abstraction following the classic OSI model, which through SDN falls initially to just 3, and then 5 years later the developers, including Scott Schenker, had to admit it was at least 5 layers, which maybe on reflection is more like 8 or more. Sure, the current abstractions, which are really IP-centric, need to change. We must move away from everything being tied to an IP address. In reality though, these new abstractions are really developed around distributed layer 2 switches whose forwarding tables are managed by a logically centralized controller, the SDN controller, from the likes of Beacon, Floodlight or Open Daylight. It's the controller then that does all the magic and should be able to control switches from different manufacturers. This is made all the more easier if the manufacturers agree on a common channel between the switch and the controller. This is where the work of the Open Networking Foundation, the ONF, comes in the shape of OpenFlow. In some cases this is where it goes out again as well, as manufacturers posture in order to gain dominance in this market. Just look at Cisco's application-centric infrastructure and its statement that it supports OpenFlow amongst other protocols. The controller's job is to provide a platform for applications, where these apps are provided with an abstracted view of the network elements through application programmable interfaces, APIs, and thus, using REST, Java and Python, can rustle up a myriad of applications across this new paradigm. They can order network resources on demand to meet their service needs. Many of the levels of abstraction are factually hidden within the SDN controller. Network function virtualization, NFV from Etsy, we are seeing network elements being virtualized as VMs in data centers. And where these data centers are more than one and are distributed around the typical service provider's real estate, this drives demand for networking both within servers, data centers and between data centers, ideally where the servers order network resources when they need them using SDN. Perhaps we have a backup application on the server which could request bandwidth from a bandwidth broker. This is scheduled in advance, and then when the calendar comes around to the allotted time, the server starts up, the network resources are already there, thanks to the bandwidth broker and SDN application, which has ordered up the network resources, probably using the services of a flow-based app, or perhaps a traffic engineering app, or a combination of both of them. All of this begs to be centralized, which is a basic tenet of software-defined networking. Even complex functions such as firewalls could appear as an application of SDN, perhaps distributed across several apps. But the firewalls through SDN will have visibility and control over all the network elements and can choose the optimal position of rules to enforce a particular firewall policy. In fact, many in the SDN fraternity believe that you do not have to upgrade your whole network, but just have the intelligence of SDN at the edges, or anywhere where most of the traffic flows, such as an interconnect between operators. Another mantra being touted is that controllers can be deployed on commercial off-the-shelf x86 processors, especially when you consider the major advances that Intel has provided to the virtualized world through its virtualization technology across all walks of life and especially aimed at hypervisor vendors. But when you scale things up to a full telco class solution, don't you want something more than a few PCs? Of course we do. You'll most likely be purchasing high-end servers with the latest CPU, memory and storage techniques and not going to some rummage sale down at HP or IBM. And the switches themselves will most likely be using ASIC switches and the like, as here we really do need hardware performance, especially with the expected traffic volumes that we're going to get. An epic milestone in SDN was probably reached when Google, with their own version of an off-the-shelf SDN router, deployed an SDN solution interconnecting their global data center in 2012. Well, almost. They have 2 networks, where iScale is the one we connect to for Gmail and searches. They did not touch this for obvious reasons. But, however, they did have a go at their internal data center network G-scale and did a very fine job of switching this over. Other players such as Huawei claim a number of firsts in the world of SDN. For some people, the coming years are probably going to be the most important, and we should then have a good understanding of whether SDN has shone or gone. Only time will tell. There is one other positive contribution from SDN in the shape of generalized MPLS, which is already being used as the centralized controller for the control plane of modern optical transport networks, or OTNs. However, this may highlight one of the other issues facing SDN, and that is the integration with different vendors, the East-West relationship or orchestration. Many people have foretold of a time of cross-vendor solutions, but there is very little standards work in this space. That said, the ONF has a working group looking at the very problem and another looking at the standardization of the northbound interfaces towards applications to match their exploits with OpenFlow in the south. This may look like a conflicting list of arguments with no clear direction either way, and if anything, best sums up the landscape. One thing is clear, that there is a desire to move away from packet-based delivery using IP addresses, to move further up the protocol stack and address entities by name, and then let the clever SDN stuff build the layer 2 path between the endpoints, on demand, on time, with little latency, and then manage any outages that might come our way. There is one final fly in the ointment, and that comes in the shape of the volume of additional control messages that will be needed to control these remote devices, and more especially when things go wrong. Well, the last point is easy. Just move some of the functionality back out to the switches, so that they can look after that without unduly loading the network. So, just what functionality gets centralized and what not? Scott Schenker says, centralize what you can. And it's these quick wins which will drive SDN, and hopefully greater things will follow. The no-brainer for this is developing SDN in the data centers, and then after that, the world. Thank you for watching my short video on SDN, and I look forward to seeing you on many more videos from Ray Castle.